Suppose a six-sided die is rolled 5 times. Find the probability of A getting exactly 1 4, B getting no 4s, C getting more than 1 4. Okay. Well, a six-sided die would create like an experiment. I do it 5 times, so that's 5 experiments in a row. And all of these are about how many 4s I get. So if I define success as getting a 4, then what I've done is the same experiment multiple times where I've counted how many successes there are. So that makes it a binomial random variable. So what if I go let x be equal to the number of 4s in 5 rolls, then x is going to be a binomial random variable because I've done 5 trials and each of them has the same probability of success. So it's 5 trials and the probability of success is 1 out of 6 because only one of the numbers is 4. Okay. And then I can use the formula for the probabilities that go with the binomial distributions to figure it out. So let's see, the probability of getting exactly 1 4 would mean that the number of 4s, which is called x, is 1. And the formula for the probabilities goes, normally this would be called n, and this would be called p. So n, choose x, which is 1. Okay, 5 choose 1. Times p to the power of the number of times you've got it, so 1 6 power of 1. And then I'm going to need to do the rest of the probability, which is 5 6, to the power of the rest of the trials. So there's 5 trials total, so 4 is the number of rest of the trials. Okay, now 5 choose 1 is a number of ways to choose one thing out of 5, so that's 5 ways because there's 5 things that you could choose. All right. And that's 1 6 because that's 5 powers, 5 to the power of 4 over 6 to the power of 4. Okay, so I get 5 over 1 technically, 5 to the power of 5 over 6 to the power of 5. Well, that's kind of cool. So 5 6 to the power of 5. So I'll just get my calculator to do that. 5 divided by 6 to the power of 5 is 0.4019. Yep, okay. All right. B, probability of getting no 4s. Okay, so no 4s would mean that the number of 4s is 0. So the number of 4s, that's what x stands for, is equal to 0. Okay, so it's still 5, but this time choose 0. We'll have the probability of success to the power of 0, which is how many times the success has happened. And then the rest of the probability times the rest of the trials, which is all the trials. Okay, so 5 choose 0 is 1, because that's not choosing any. There's only one way to not choose any of them to have successes. And then 1 6 to the 0, that's 1 as well. So anything to the 0 is 1. So anything choose 0 is 1, and anything to the power of 0 is 1, okay? And then I've got 5 6 to the 5. Oh, that's the same answer as the other one. Well, that's interesting. I dare say that wouldn't happen very often. All right, well, I'll move on. All right, C, probability of getting more than 1 4. Okay, so the probability of more than 1 4, so the number of 4s is more than 1. So the number of 4s is x is more than 1. So I can use greater than here. Okay, so that would mean that I could have 2 or 3 or 4 or 5 4s. So I could figure out all of those probabilities separately and add them up. Or I know they all add up to 1, and so I could take off the probability of being the opposite of this. So let's see, 1 minus the probability that x is less than or equal to 1. because these two together cover all the possibilities. And I know that being less than 1 is the same as either being 0 or being 1, and I have both of those probabilities already. So that would be 1 minus, now I could use these decimal ones, but I'm afraid I rounded them off, so I might just use the original formula so that I don't get it wrong. So let's see, that was 5, 6 to the 5, and another 5, 6 to 5. Okay, so if I just put in my calculator 1 minus 2 lots of 5, 6, whoa, 6 to the power of 5, so I get 0.1962. Okay, so it's really much more likely to get 0 or 1 fours than to get anything else. The median is therefore 1, I reckon. Yeah. All right. Well, there we go. I've managed to use the formula for doing probabilities with binomial distributions to figure out these answers.